Have you ever used an AI chatbot and gotten an answer that sounded incredibly confident, incredibly sure of itself, only to find out later it was completely wrong?
Oh, all the time. It'll give you a date for a historical event with such certainty, and it turns out it's off by a century. It's a bit unnerving.
It is. We're naturally wired to trust confidence, but a new paper is suggesting that with AI, we might need to do the exact opposite.
Welcome to Daily Papers, the podcast where we break down fascinating new research. Today, we're looking at a paper called Epistemic Observability in Language Models by Tony Mason, and it starts with a finding that should make everyone sit up and pay attention.
It really should. The very first sentence of the abstract is a bombshell. It says, models report highest confidence precisely when they are fabricating.
Wow, okay, let's unpack that. What exactly do they mean by fabricating?
It's a polite academic term for making stuff up. You know, when the AI generates a plausible sounding but completely invented fact. Sometimes people call it hallucinating.
And how did they measure confidence?
This is the wild part. They literally just asked the models things like, how confident are you in this answer? And when the models gave correct, factual answers, they'd say they were moderately confident. But when they gave these fabricated, made-up answers, they reported being highly confident.
So their confidence is literally inverted. They are least sure when they are right and most sure when they are lying.
Exactly. The researchers tested this across 4 different major AI models, and the finding held. They use a metric called AUC, which is just a way of measuring how good something is at telling 2 things apart. A perfect score is 0.1, a random coin flip is 0.5. The model's self-reported confidence scored between 0.28 and 0.36.
So they were worse than a coin flip at telling you if they were being truthful. Following their confidence was actively misleading.
Actively and reliably misleading. So the huge question is, why? Are these AIs just fundamentally broken?
Well, this is where the paper gets really interesting. The author argues this isn't a capability gap, meaning it's not that the AI isn't smart enough, it's what they call an observational gap.
An observational gap. What does that mean?
Imagine you're a food critic, but you're not allowed in the kitchen. The only thing you get is a single beautifully styled photo of the final dish. You can't see the recipe, the ingredients, or the cooking process.
Okay, so if the chef burned the main course but is a genius at food photography, I'd never know. I'd just see a perfect-looking meal.
Precisely. The paper argues that's how we interact with language models. We send them a text prompt and we get a text answer back. We only see the final polished photo. We don't see any of the cooking that happened inside the model's neural network.
So the AI might, in some sense, know it's just winging it, but the final text it produces is so smooth and confident sounding that we have no way of knowing.
That's the core idea, and the paper actually presents a formal proof, an impossibility result. It basically says that if your only tool is observing the final text, it is mathematically impossible to create a system that can reliably tell the difference between an honest answer and a convincing fabrication.
So trying to fix this by just training the AI to be more honest with its words is a dead end.
According to the paper, yes, because you're still just judging the final photo. You're training the AI to become a better food photographer, not a better chef. You're training it to produce text that looks more honest, which it can do even when it's fabricating.
This sounds pretty bleak. If we can't trust what the AI says, and we can't even trust it when it tells us to trust it, what do we do? Is there a way out?
There is. And the solution is to stop looking at the photo and start looking at the data from the kitchen. The paper proposes something called a tensor interface.
That sounds technical.
It does, but the concept is really intuitive. A tensor is just a data structure models use internally. The idea is, instead of the AI just giving us the final text, it should also give us some of its internal telemetry, data from its own thought process.
So back to our kitchen analogy, it's like getting the photo of the dish, but also a printout of the oven temperature, a list of ingredients it considered using, and maybe a log of how long the chef hesitated at each step.
Exactly. And the paper focuses on one incredibly useful piece of telemetry, something called per-token entropy.
Okay, you're gonna have to define that one for me.
For sure.
A token is just a word or a piece of a word, and entropy here is basically a measure of the model's uncertainty. When the model is generating text word by word, high entropy means it's very uncertain about what word should come next. It's juggling a lot of possibilities. Low entropy means it's very certain. It knows exactly what word it wants to say.
You got it. When it's making up a fluent, plausible-sounding lie, it's not really thinking hard. The words flow easily, one after the other. It's very confident, so the entropy is low. But when it's trying to recall a real, perhaps obscure fact from its training, it's a bit more hesitant. There is more uncertainty. The entropy is higher.
So the internal signal, the entropy, tells the exact opposite story of the external signal, the self-reported confidence. The hidden hesitation reveals the truth.
That's the key, and the researchers put this to the test. They created a cost surface, which is a fancy way of asking, if you only have the time or money to fact-check, say, 20% of the AI's answers, which 20% should you check to get the most bang for your buck?
And how did the new method do? It worked incredibly well. If you used text-based clues like how long or complicated an answer was to decide what to verify, your overall accuracy got a bit better. But if you used the entropy signal, checking the answers with the lowest internal uncertainty, your accuracy got a much bigger boost.
So by looking under the hood, we can build a much better lie detector.
A significantly better one. And it works because it's a signal the model can't easily fake. For the model to fake its entropy, it would have to fundamentally change its own computation, which would likely just make its answer worse. It's a bit like trying to fake a genuine stutter.
So to wrap this all up, the big scary problem is that language models are most confident when they're making things up.
Right, and the reason isn't that they're dumb, it's that we're effectively blind. We only look at their final text output, and they are masters of making that text look good.
But the solution is to demand a better window into their process. By looking at internal signals like entropy, which measure the model's computational uncertainty, we can get a much more honest picture of whether the model is stating a fact or just spinning a yarn.
Exactly. The paper's conclusion sums it up perfectly. Honesty in AI is not a capability problem, it's an observational problem. It's not just about building bigger models, it's about demanding better tools to see what's really going on inside them.